All right, well, we're going to start by reviewing some things that we talked about in our last lesson. In our last lesson, we talked about how to construct a proportion, specifically how to construct a fourth proportional. And so if you would, I want you to go ahead and draw 3 lines on your paper. Let's make the first line 1 1/4 inches. 1 1/4 inches. So 1 1/4 inches. Remember, each little tick mark typically is a 1/16 of an inch. So 4/16 would be a quarter. So you go 4 tiny tick marks. You should notice a rather longer tick mark for the 1/4 inch. Then if you would, make a 7/8 inch line. That's going to be 2 tick marks shy of the 1 inch mark. Make a 7/8 inch line. Again, that'll be 14/16, 2 tick marks shy of 1 inch on most rulers. Now, if you only have 8 tick marks to the inch, then you know that each one's 1/8, in which case you would go 1 tick mark less. Okay, so using a little bit of common sense reasoning there. And then let's go with a slightly easier one. Let's go with 2 1/2 inches for our next line. And we want to construct x so that 1 1/4 is to 7/8 as 2 1/2 is to x. 1 1/4 is to 7/8 as 2 1/2 is to x. So we're constructing a fourth proportion. Now realize, if the x happens to be in the 3rd spot for some reason, what would I do?
Like inverse.
Invert both of them, inversion, transformation. What if the x were in the 2nd spot? What would we do?
Rotate and flip? No.
We could alternate the means and then invert both ratios, or we could just write the fractions in a different order because they're equal anyway, right? And if it were in the 1st spot,
Alternate.
quick alternation would put it in the 4th spot. So again, even if a proportion doesn't have x in the 4th spot, you can put x in the 4th spot easily enough. All right, and what do we need to do to construct this fourth proportional? Kendall, start us off. Good, draw 2 long lines. They're going to be the sides of a triangle. Then what, Genesis? Good, measure whichever line is in the 1st spot of the proportion, which is the 1 1/4 inch line. And then once I've measured it, from the vertex, go up to the vertex, mark off your 1 1/4 inch. All right, then what do I need to do, Ethan?
The next one.
So measure the 7/8 inch.
The arc you just made.
Good, so mark it off in succession with the first. So where the first one left off, the second one will begin. There's our 7/8 inch. All right, Jamie, now what?
Measure the last, the 2 1/2 inches.
Measure the 2 1/2. There we go, the 2 1/2 inch segment.
From the vertex on the other side.
Ah, so we don't mark this one off in succession. We go back to the vertex and go on the other side to mark it off. All right, Chris, now what?
Draw the parallel from the 1st to the last.
Good. Connect the end of the 1st to the end of the 3rd segments. This is essentially the parallel in Theorem 53, but we're starting with this because we have 2 points that can determine the straight line. See, then what? Audrey? Good. This angle right here at the end of the 1 1/4, we want to copy this angle and put it right here to make a, construct a parallel. And you will want to make sure your compass is open less than, ideally less than 7/8 of an inch. We're going to have to fit this measurement here in just a minute. Once we've got the measurement, of course, we will connect the dots. Straight edge slipped a little bit there. And last of all, if you would, go ahead and measure your fourth proportional. It should be exactly 1 3/4 inches. Should be exactly 1 3/4 inches. And mine's a little bit off.
I'm going like a little bit brain dead right now. Can you show how to cut the angle again?
All right, let me show it again. I just did it a moment ago if you've been watching.
I was trying to do it on my
You put the point of the compass here, make an arc.
Yeah.
Then go down here, make the arc.
Yeah.
Measure across this arc. Mark off the same distance on this one. All right, anyone get exactly 1 3/4 inches? Jamie, you did. Almost. How many really close to 1 3/4? Maybe a nudge off. All right. Questions? Do your lines at least look parallel?
They do look parallel, but I got 3 inches.
3 inches. Well, they don't quite look parallel. One thing that's missing here, Quentin, I would say, is this initial arc when you measured across. If you'll make this arc, you notice I always do that to make sure my measurement's just right. Yeah, possible there was some slipping of the hand there. All right. That looks good. That looks good. And good. All right. How about this? Draw 2 more lines now, if you would, please. Go ahead and draw 2 more lines, if you would, please. And we want to construct the third proportional to 1 inch and 1 1/2 inches. I want to construct the third proportional to 1 inch and 1 1/2 inches. So if you would go and draw 2 lines, make one of them 1 inch and the other 1 1/2 inches. We'll make a 1 inch line and a 1 1/2 inch line. I want to construct the third proportional. One thing that will help you is if you'll go ahead and write out the proportion that we need to use here. What would the proportion look like for the third proportional to 1 inch and 1 1/2 inches? Quentin?
1 is the x is to 1 1/2.
Well, that would be the mean proportional, where 1 1/2 is the third proportional, but I want x to be the third proportional.
So 1 is 1 1/2. That's 1 1/2.
There we go. To have a third proportional, you must have a mean proportional. So, if this is your 1 1/2 as one of the means, the other mean must be as well. Now, had I said construct the third proportional to 1 1/2 inches and 1 inch, now what would that proportion have looked like, Chris?
1 and 1/2 over 1 equals 1 or less.
Right, then the 1 would have been the mean proportional. Does that make sense? All right, but we're going to roll with what we initially had here, with the 1 is to the 1 1/2, as 1 1/2 is to x. At your seats, go ahead and do the construction. When you finish, measure. See if you got 2¼ inches. And again, I am slightly off. All right, what did you have, Ethan?
I had almost 3. I had 2 and like 7/8. I just slipped, I think.
You have 2 7/8. So you were a little bit too big. I was close. If I adjust for how I drew it to scale, I was about 2 1/3. How did you do, Genesis? 2 inches, so a little on the smaller side. How about you, Kendall?
I
Got it. Wow, good. Audrey?
got it.
Under 2 inches. Okay, so you were considerably shorter. Jamie?
A little bit over the 2.
Nudge over 2 1/4.
2 and 7. 2 and 7.
2 1/2. 2 7/8. Okay, yeah, that's kind of big. All right. Questions on how to do the construction. Again, the hard part is making sure we get the angle just really exact.
Right.
Again, make the little mark to make sure that we're right there where we need to be when we copy the angle. We also talked about how to divide a line proportionally to given segments. Now, previously we divided a line into equal segments, any number of equal segments, but now we want to talk about how to divide a line proportionally to segments. So if you would, on your paper, go ahead and draw a 1-inch segment, a 2-inch segment, and a 1.5-inch segment. So 1 inch, 2 inches, and 1.5 inches will be our segments. Then if you would, draw a 3-inch long line. Then if you would, draw a 3-inch long line. You understand you cannot divide 3 inches into 1, 2, and 1.5 inches, right? You would need a 4.5-inch line to do that. But we can divide it proportionally to 1 inch, 2 inches, and 1.5 inches. What would we need to do to divide this given line proportionally to these 3 given segments, which I'll call A, B, and C? I'll start with Quentin this time.
Draw a long line with 1 endpoint, draw the 3 endpoint.
Good. I usually come off the first endpoint, but it really doesn't matter which endpoint you use. But draw a really nice long line coming off at an angle. Really, it needs to be at least 4.5 inches long, right? Then what do we need to do? Audrey? Measure A and? Starting at this connector point, the first end point, mark off A. Then, of course, Chris?
Mark off the 2 inch.
Good. Measure B, the 2-inch segment, and mark it off.
At the end of the 1.
Good. So in succession with the A, or the 1-inch segment. And then finally, Jamie.
You measure the last one, the 1.5.
You measure the 1.5-inch segment, the C, and of course,
In succession.
mark it off in succession. If we so chose, of course, we could label these 1 inch, 2 inch, 1.5 inches. You could also go through and maybe mark these dots a little bit more strongly. Could scribble off the extra if I so chose. Then what should I do? Ethan?
Get it out of the top line, the endpoint, to the bottom.
Go to the end of that last segment, that 1.5-inch segment. Connect those down. Seems to make a right angle here. Doesn't necessarily mean it has to be a right angle. It just appears to be so. All right, Genesis, then what? Good. Go to the very bottom of the ice cream cone. make an arc. So putting the dot at the last dot down here, make the arc. Then, while we have the compass open this much, Genesis, could go to the next dot, the end of the 2-inch, make a nice big arc. Then go to the end of the 1-inch, and anyone see a little problem? Yeah, my arc didn't actually cross. So I've got two options. One is extend the line. The other is close the compass a little bit and start over. And I've already got the compass in my hand, so I'm just going to make littler arcs this time, rather than get the straight edge out and extend it. Now I just need to remember, when I measure, I'm measuring the little arc now. That's the downside of making extra arcs. All right, so we will, of course, then measure the little arc right there. Once I've got that measurement, Kendall. Good, on the next little arcs, there's a little and a big. Go to the little, mark it off, and then come up here to this little, mark it off. And then, good, connect these intersections to the dots at the end of the 1-inch and 2-inch segments. And we've got our segments A prime, B prime, and C prime. And they are in ratio 1 to 2 to 1.5. All right, questions on this? How about this? If you would on your paper, go and draw a 4-inch long line. Draw a 4-inch long line now. We want to divide this line in ratio 2 to 3 to 1. We're going to divide this line into parts in ratio 2 to 3 to 1. There's a couple ways we could go about this. Thoughts?
Make it 4.
Okay.
2 is 3 is 1 is 4.
Careful. We're not saying that this 4-inch line is in the proportion with these other things. We want to chop it into pieces, 3 pieces that are proportional to each other in ratio 2 to 3 to 1.
2 is to 3 is 1 is to x.
Well, again, that would give me a fourth proportional to 2, 3, 1, and x. But again, it's not 2 is to 3 as 1 is to x. It's 2 is to 3 is to 1. They're all in a 3-part ratio here. Algebraically, how would I represent my 3 segments, class? 2x, 3x, and 1x, right? And I could say that the sum would have to equal 4, right? Algebraically, we could solve, but we want to do this with a construction. I'm sorry? Okay, let's follow Quentin's train of thought so long as it does not derail. All right, Quentin, what are you thinking after we draw this long line? That's all he had was the long line. Okay, well, we're dividing a line proportionally, so that's a good start, is draw the long line. Chris?
Make the lines 2 inches, 3 inches, and 1 inch.
Ah, you see, x could be anything, couldn't it? It could be inches. Now, that's pretty big, though, right? An inch, 2 inches, 3 inches? What if instead of inches for my x, we made it centimeters? Why not make a 2 centimeter line, a 3 centimeter line, and a 1 centimeter line? After all, those will be in ratio 2 to 3 to 1, right? So, yeah, let's do that. That's one way to do it. So let me flip this over and go centimeters here. 2 centimeters, 3 centimeters, and 1 centimeter. That's kind of small though, isn't it? It's be kind of tiny, but inches would be almost too big.
Why don't we make it 2, 6, and 4?
I'm sorry?
Why don't we make it 2 centimeters, 6 centimeters, and 4 centimeters?
You mean 4 centimeters, 6 centimeters, and 2 centimeters? Do you realize, class, that 4 to 6 to 2, if we use x as 2 centimeters, these are still in ratio 2 to 3 to 1, aren't they? And it gives us me a little bit more room. So yeah, let's roll with 4, 6, and 2 then. So there's the 4. There's the 6. And there's the 2. And that's just going to fit just a little bit better, I think. So 4 centimeters, 6 centimeters, 2 centimeters. And again, the idea here is it doesn't matter what unit you use. I know this is inches. This can be centimeters. Doesn't really matter as long as these all have the same unit, and they do. So we kind of use the X to be a 2 centimeter long X. All right, guess we just do what we did last time, right? Measure, mark them off in succession. So go ahead and do that. Measure, mark off. Measure, mark off. Uh-oh. Measure, I've got a feeling it's going to be a little bit too long. That's okay, I can always extend the line. Oh, are you kidding me? Missed it by that much. Oh, well. I almost don't need this straight edge to extend it.
Whoa, whoa.
It's gonna be inaccurate.
All right.
Ooh, this is gonna be hard.
Of course, once we've marked those off, we need to connect the ends up here. Again, I didn't have very much excess here to need to worry about scribbling it. Here are my segments, which actually, I believe, would be 2/3 of an inch, 2 inches, and 1 1/3 inches. If you're ever wondering, how do you construct thirds of inches? Well, there you go. The only one that's easy to measure would be the 2 inches, so maybe check and see, did you actually get 2 inches for your middle segment? Again, thirds are rather challenging. I'm just a little bit off.
I got a little bit over 2.
I'm sorry?
Yeah.
A little off.
A little bit over 2 for me.
Okay. Right on. Ah, good job. So that presumably means your 1 1/3 and your 2/3 are also right on. Now, of course, if you're looking at the ruler, 2/3 of an inch, that would be 0.6 repeating, right? So as we look at the ruler, okay, for instance, here's 0, here's 1. This right here is the 1/2. That's 0.5. Then you've got your 0.25 and your 0.75. And if you kind of found your 8ths, well, right here would be 0.625. So the third should be right about, or the 2/3 should be right about there, just beyond the 5/8 mark, maybe, if you were measuring. But again, that's kind of inexact. Questions on dividing the line? Did anyone think of another way we could do this same construction? We'd actually done one like this before,
Do the same thing.
where we would open your compass any amount, mark off 2 of them, make a dot, mark off 3 of them, make the dot, assuming your line was long enough, and then mark off 1 of them, because you opened your compass X, literally whatever you felt like, as long as you had 2 of them, 3 of them, and 1 of them. But this method works. Nothing wrong with it at all, and I especially like he was willing to think outside the box of, hey, it's too little, we could double it. But really, it could be any amount we chose to open the compass. Questions on that?
I hate this and auxiliary.
Hey, at least you had an idea, and it worked. There was nothing wrong with it. So nobody else had any ideas. So good job, Chris. All right, he thought of drawing a big long line. Okay, props to Quentin. He went out and given his dues. All right, get the sheet of paper that has the reinforced edge. We're going to move on to our next construction. And earlier, someone kind of mentioned a mean proportional. Well, we can construct those too. So construction 19, constructing the mean proportional to two given segments. Constructing the mean proportional to two given segments. Construction 19, construct the mean proportional to two given segments. Now again, we've got to be able to prove our construction works. So we need to think of a picture that involved a proportion, specifically a picture that involved a mean proportional.
Construction 17.
Well, construction 17 didn't involve a mean proportional necessarily.
But it could have.
It could have. Let's think about that. Let's suppose we wanted a mean proportional. Let's just say A and B. Then we would need to mark off our A, and we're not sure where to mark off X, right? But wherever we would mark off X, which we don't know, we would mark off over here. And then whenever we're finished, from wherever it is, we would mark off B. But I don't know where to start B. Do you see that really isn't going to work out so well? So now we can't use the same picture as construction 17. Think back to the pictures and proportions.
Do you have the one where we had the lines with the parallels?
Well, that would divide a line proportionally to some other things, but I don't know that it would necessarily divide into a mean proportional.
Is it the one with where you
Quentin's smart. He's getting out his notebook, looking at that pictures and proportions.
I'm not a cheater.
All right, Ethan's not a cheater, so let's see if he can get it right, because otherwise he'll just be a wrong non-cheater.
The one that's is the one with the segment is to segment, or whatever, side to side.
Well, is there a mean proportional in segment is to segment, side is to side? Only if one of the segments happens to be exactly equal to the
Altitude
side.
and secant.
What?
I said altitude and secant.
Altitude and secant?
The given segment would be mean proportion. Secant is the secant is tangent is tangent is.
Okay, secant is to tangent is tangent is extra. So let's picture this for a minute. If I were to draw some circle, and I were to draw some random secant, any random secant, this length could be the first, the bigger of the two given values, right? Two given segments, as long as I make the big segment here and the small segment here. You realize then if I could construct a tangent from that point, that would be the mean proportional. That could work. Let me talk through how this would work. Suppose we had these two segments. I would call the bigger one secant. I would call the smaller one external segment. I'd draw any random circle I wanted. I would pick any random point I wanted. I would draw any random long line I wanted. I would measure the secant, mark it off. Nope, not any random line I wanted, because this specific external segment would have to fit there. What if, though, forget the circle for starters. What if instead I started by marking off the secant, and then from here I marked off the external segment? The circle would have to fit inside this loop. I could construct a perpendicular bisector. I could pick any point on the perpendicular bisector, and that would give me, pardon the drawing, a circle that has a secant and an external segment. Then remember, if I connected these points, connect this point to this point, perpendicularly bisected there, and then open my compass up some amount, either of these lines would give me a tangent. That would work. Do you get the idea that it's pretty complex? There's a slightly easier one, but that would work, Chris, to your credit. But I'm going to teach you a little bit of an easier way. So we have another picture that involves a mean proportional. Chris gave us one that does work. Because if it's a picture with a mean proportional in it, we can construct it, right? I just showed how we would.
Is altitude the segment?
Okay, now Ethan's thinking of the right triangle, right, that had the altitude.
That green here.
So then this segment could be one of my given lines. This segment would be the other given line. So as long as I could construct a perpendicular between the segments, the hard part, how do I get a right angle up here somewhere? Remember, any angle inscribed in a semicircle is a right angle, correct? So if I could just locate the midpoint of this, put a semicircle around, wherever the semicircle cuts the perpendicular, that would be the mean proportional. This is going to be the picture we're going to use. It's just a little quicker and easier to use. So we're going to base off of this picture here, where the mean proportional is going to be this. If you would, go ahead and draw a couple of lines of varying lengths. Don't make them too similar or you're going to struggle. So make them different enough.
You recommend smaller, bigger?
Not picky on which one's which. So I went small first, then large, but it doesn't really matter. Let's call them A and B. Remember, this is my template. This is my sketch. First of all, I want to mark off the segments, but I need a big long line to do so. So down the bottom third of the paper, step number 1 is to draw a big long line. Draw a big long line. You probably saw that coming. No, I tricked you the other time where I had you draw 2 long lines. So this one is only 1. What do you suppose after we've drawn the big long line? Give yourself some room above it, by the way. So I put the big long line just a little bit above where you started your direction. So step 1, draw a big long line, just like a line or 2 or 3 above it. That's where you should probably draw your big long line. Give yourself some room to work up above, because that's the direction our construction is going. Right? We look at the sketch, everything's up above the long line. All right, now what do you think we would do?
Mark off line A.
Mark off the segments in succession. That's step number 2. Mark off the given segments in succession. I don't know that we need to write on the big long line. I believe that's probably understood. So here's A, here's B. You know me, I'm a scribbler. I scribble off the extra. So if we're marking what I know this point, I know this point, and I know that point. What do you think we might do next? Somebody else?
Would we draw the perpendicular at the first arc or something?
Yeah, right here where the first segment ends and the next segment begins, let's put a perpendicular. Step 3, construct the perpendicular between the segments. And in parentheses put construction 4, C-4. Construct the perpendicular between the segments. Remember, put the point of the compass right here between A and B, right at the end of A. Open it a little bit, make little marks. This is step 3. This is construction 4 that we're doing here. So construct the perpendicular between the segments. And in parentheses, construction 4. When you draw your perpendicular, make it nice and long. You'll remember when we did our unmemorized constructions, that was my strategy tip. You understand, I need this point right here. Once I know where the semicircle crosses the line I just drew, I'm good. So, really all I need is a semicircle, right? But in order to draw a semicircle, I need to know how big to open the compass, and I need to know where to put the point of the compass. What next? Somebody else. I need to hear from a lady. Ethan, stop looking at Brecken. He's not in this class.
You said you needed to hear from a lady.
I'm just picking on you,
Wow.
Brecken. There you are trying to do your work like a diligent student, and Mr. Nasty picking on you, I tell you. It's a rough life, getting bullied at school by the teacher. All right, ladies, come on, help me out.
Peter.
I need to know where to put the point of the compass, and I need to know how big to open it. Alright, so if I put the point of the compass here, that would give me a semicircle. No, B is too big. I need something smaller than B. Okay, so measure A,
Oh, I see what you're saying.
and but that's too small. Jamie?
The perpendicular, like where the perpendicular meets the line.
Yeah, that's what Genesis was saying, is measure A, and then make your semicircle, but if you kind of picture it with me, Jamie, it's supposed to hit this point over here, right? The semicircle has to start here, like shown in the picture, and come all the way around to there. Like, as if A plus B were the diameter of the circle. So where do I put the point?
Why don't you get a midpoint and measure the radius?
Well, I was gonna have a lady help me with that, Chris, but Kendall's over there like nodding her like that's what I was gonna say. I was gonna say that. Yeah, let's find the midpoint. If we could find the midpoint of A plus B, wherever that is, then my semicircle would hit perfectly, right? So that's step number 4. Find the midpoint of the sum of the segments. Find the midpoint of the sum of the segments. And in parentheses put C-1, construction 1. Find the midpoint of the sum of the segments. So remember, for the construction 1, you had to go to one end of A plus B, open it more than half, and then make an arc above and an arc below. Go to the other end of A plus B, make an arc above, make an arc, oops. See a problem? Yeah, but you know what I can do? Shorten my compass a little bit. Hey, there we go. You say, oh, but the marks up there weren't. Remember, as long as this point is equidistant from the ends, and as long as this point is equidistant, even if it's a separate distance, as long as this point's equidistant from the ends, those 2 points will determine the perpendicular bisector. Now, ideally on your paper, even though it might have gone down into where your directions are being copied, you can still find that point. And I'm going to draw this either very lightly or perhaps as a dotted line, because I don't care about this perpendicular. I care about the other one I drew. The only reason this line exists is because I wanted that midpoint, which I'm going to label right there. So that's the only reason for this line. So I always draw it either dotted or very, very lightly, because I don't care about this line. All I care about is the midpoint. And step number 5, you can assume, is to construct the semicircle. Construct the semicircle. Put the point on the midpoint, measure to either end, or if you're like me, you measure both. And there's my semicircle. Now, if you wanted to, once your semicircle's drawn, you could connect the dots here and here to get your right triangle. But technically, I don't need to draw this, because all I wanted was the mean proportion of x. And I now have it. It goes from up here to down there. Questions on the construction? Do we understand the thought behind it? You're copying the right triangle with the altitude. Yes, ma'am.
How did you do the semicircle?
All right, you first of all have to bisect the whole A plus B. Notice how I marked A plus B is all of this? You have to bisect the whole thing. So open the compass more than half of that. Go up here, arc, arc. Keep it open the same amount, go over here, arc, arc. When you connect the dots, it gives you the midpoint. If you'll measure midpoint to the end, you'll get a semicircle. And wherever the semicircle crosses that perpendicular that you drew in step 3, that's your mean proportional. Questions? Any other questions? Flip the paper over, let's practice. Flip it over, let's practice again. This time, I want you to start by drawing a 1/2 inch line. A 1/2 inch line. Then I want you to draw a 2 inch line. So start with a 1/2 inch line, then a 2 inch line. And we're going to construct the mean proportional to a 1/2 inch and 2 inches.
Trying to torture us?
Nope.
Yes.
All right, so what do we do first?
The line.
Big long line. Make sure it's at least 2.5 inches, preferably longer. Since we don't want to actually have to think about what we're drawing, we just want to draw really big. As long as it's at least 2.5 inches, we're good, because our next step is to measure and mark off the segments in succession. So I'm going to start with the little 1/2 inch line segment.
Can we make it 1 inch and 4 inches?
Nope.
This is brutal.
There's my 1/2. There's my 2. All right, then what? Oh, let's scribble off the excess.
Scribble off the excess.
All right, then what?
Draw perpendicular.
All right, let's put the perpendicular there. Now, for some of you, opening your compass less than 1/2 may be problematic for you. So what you could do is you'll dot these 3 points. You may extend this line a little further out if you need to. Just use the straight edge to do it. I'm not going to, but you may need to with your
Has some compasses.
matched up compasses, yes.
I'm not good.
All right, now what? Sorry? Midpoint. You should be thinking semicircle, but you can't get the semicircle without the midpoint. So now remember, you're going to have to open your compass up enough that you can make it halfway from start to finish. So open it at least halfway. Arc above and below. Arc above and below, and it just fits on the chalkboard. And again, this perpendicular bisector probably ought to be really lightly drawn, so you don't get it confused with the other perpendicular. That would be a bummer. All right, there's my midpoint. And the reason I needed the midpoint was for the semicircle. There's your mean proportional. Once you're done, check it. It should be exactly 1 inch.
Yep.
Mine is just a tiniest bit off.
Yeah, mine is literally like barely there.
Mine's
Tiny.
perfect. Right on.
All right,
Mine's
you got it
mine's
right
less
on.
than 1/4 inch. I like way less than 1/4 inch.
Questions on this construction? All right, for homework tonight, you're going to do 3 constructions. For homework tonight, you're going to do 3 constructions. Jot this down carefully, please. First of all, we want to construct the 4th proportional to 1 inch, 2 inches, and 3/4 of an inch. Want to construct the 4th proportional to 1 inch, 2 inches, and 3/4 inches. Then we want to construct the mean proportional to 4 centimeters and 9 centimeters. Finally, I'm going to have you divide a 3.5 inch line proportionally to 2 inches and 3 inches. Divide a 3-inch line proportionally to 2 inches and 3 inches. We're going to divide into 2 segments. They're in ratio 2 to 3 essentially, but divide proportionally to 2 inches and 3 inches. We'll go over that tomorrow. And we'll continue practicing with these. Also introduce one more construction in our next lesson, Friday, which is lesson something, I don't know, lesson number 1. But Friday, in just a few more lessons, we're going to take a quiz over these constructions. All right, with the bell rings, you are dismissed. Have a wonderful rest of your day.
We only did 3.